All right, we're going to get started because we're butting up against lunch, so if we can get started a little early and then everyone can get to lunch, I'm sure everyone will be pretty happy about that. So we're going to be talking today about client virtualization tool stacks. We're going to be doing essentially presenting a client virtualization tool stack that we came up with in Golang. Here we go. All right, so just a quick overview of what the presentation is going to cover, an introduction of us two who've been working on this project, the motivation behind it, some alternatives that we evaluated, the tool stack that we ended up coming up with, and some discussion on improvements to the basically doing libxl Go bindings. There are some that are in tree now that have some deficiencies, so we're looking at addressing some of those. And finally, fielding questions. So I'm Brendan Kerrigan. I'm a principal engineer at Shared Information Security. I work on hypervisors, been working with Zen since probably 2011, mainly working on graphics virtualization and some embedded stuff.
I'm Nick Rosbrook. I've been at Shared Information Security for about a year now. Specialize with networks and VPNs. Very interested in cryptography, and I enjoy getting to spend a lot of time writing Go.
All right, so the motivation behind this is essentially at AIS we do a lot of client virtualization work. We utilize hypervisors to do some endpoint security stuff, so whether it's protecting data while it's at rest or whether it's in motion, we essentially will go ahead and utilize the hypervisor to provide some extra security guarantees, and we do this almost exclusively on the client end. We don't do much in the server space. So most of our products are based on OpenXT right now, and OpenXT provides a lot of development. A lot of it was done at Citrix and then has been done in open source now for a couple of years. And there's a lot of components in it, and some of there's a lot of legacy cruft. You can imagine over 10 years of a project, you're going to pick up a lot of stuff that you may not necessarily need or potentially doesn't even work. So if the test coverage is there, you know if something's broken or not. But a lot of the APIs that are available in OpenXT don't actually do anything, whether that some of those components were lost in the open sourcing or whether people weren't using them so they weren't exercised and they essentially are deprecated by loss of functionality. Another problem with OpenXT is that it does have a lot of requirements on different hardware features, mostly Intel TXT and some of the things that come along with that. So a lot of the vPro chipsets are required to use it in the way that it is intended to be used. So that can be a hindrance to some use cases that don't have those high security requirements. So we're looking at kind of being able to scale back that stuff and maybe introduce maybe not as good of a security posture, but a higher hardware compatibility list. And just a point here is one of the motivations is that the difference between a client virtualization tool stack and server virtualization tool stack is pretty drastic. Things you care about on the server, you don't necessarily care about on the workstation and vice versa. So there's some special concerns there, and it's, I would say, a lot more underserved in the client side than the server side. The server side is very mature because it is used very often in production. Oh, I did it again. Okay, so we evaluated some things. We didn't want to start from scratch if we didn't have to. So we essentially looked at what's already there. In OpenXT, there's Zen Manager, which is a tool stack that's been in place for quite some time. It's written in Haskell. And then libvirt, and I think the obvious piece of libvirt that kind of lends itself to client virtualization is the cubes patches on top of it. So kube control and all that. So we evaluated those, and then we talked about what if we had a clean slate, what would we want, and what are the pieces from each possible solution that we would want to start from a fresh spot. So Zen Manager is kind of a pain in the butt to work with. If anyone's ever worked with it, it's this massive Haskell tool stack that it was written in a version of Haskell that is kind of out of date, and there's no forward compatibility with it. So I think it's on Haskell 6 still, and you'd have to do almost an entire rewrite to bring it up to Haskell 7 or whatever the latest version is. There's a lot of legacy interfaces, like I said, that are unexercised and unaudited. There's a current effort in place to audit those APIs that are available there, but there's still a lot of them that are in place that just were from maybe features that never got open sourced in the transition from Zen Client XT to OpenXT and some other things. And it's pretty cryptic code. It's hard to find people to work on it. And at the same time, right now, for the most part, what it does is reads the database, writes an Excel file, and then calls XL create on that Excel file. So I think we can do that in a lot simpler of a way. Local and remote APIs are different. So if you're managing some VM instances on an OpenXT box, there's a completely separate protocol that's used. It's not unified with the Zen Manager API. On the plus side, Zen Manager's command line interface is fantastic. It's kind of a pleasure to work with. It gets pretty natural pretty quickly. Very nice autocomplete. All right, I'm going to hand it to Nick to talk about libvirt.
So when we're looking into libvirt for our tool stack, our main concern was that it was one layer of abstraction too many. libvirt is designed to work with several virtualization technologies like KVM, Zen, LXC, and a lot more. And on top of that, we found that working with their XML domain configurations could be very cumbersome. For example, sometimes we would have some expected behavior for something as simple as starting a guest in full screen, and it would produce unexpected results based on what we saw in the documentation. And that could be frustrating because we already know how to do those things well just by working with an XL configuration directly. libvirt also provides a lot more functionality than we need for our purposes. We really just want to work well with Zen. And by virtue of the fact that it is designed for many virtualization technologies, there's things in there that we just don't need. There is, however, some Go support already for libvirt. There's a Go package that's developed by DigitalOcean, has seen some use in production on their server side. And there's also actually one by libvirt themselves. But again, that's for use on the server side, which we have different needs on the client side. So what it really came down to is that there was an extra layer of abstraction that we felt was very unnecessary for us wanting to work with Zen.
So what we came up with, we call redctl. It's the client virtualization tool stack for our distribution of Zen called Redfield, which is essentially just open embedded based Zen distribution for you guys, for anyone to use. It's open source, it's out there on GitLab. But the good of it, we unified remote and local management APIs, so you can target whether you're talking on localhost or if you're talking across the internet or something like that. So you can use the same API and same tooling to manage locally and remotely. We're utilizing gRPC, which kind of makes it nice as far as code generation. And if you want to talk across different languages, that's pretty easy to do. So you can generate your code. If you want to talk to the API in C++ or something like that, it'll generate the bindings for you, and you can talk directly to the API without having to make a lot of boilerplate code. We don't dictate transport, so you can use IPv4, 6. You can do it over PB channels, Argo. Now that that's been merged into master, that's probably something that we'll be targeting. And VSOC is something that we've been looking at as potentially VSOC kind of plus Argo as an intermediary. Big pluses on Go is it's easy to understand. It's pretty easy to get junior level developers spun up on it and to have them be effective without having to hold hands or worry that they're going to be able to do something very dangerous. So it's kind of somewhat safe by default. There's a lot of complaining that Go will do to you. There's no warnings. It's always an error. So there's some properties there that make it nice to have for teams that you might not necessarily have people who have tons of experience in a particular language. You can have people spin up very quickly. And the command line tool for redctl is, I wouldn't say it's quite up to Zen Manager's kind of ease of use, but we're working on it. We have a lot of the autocomplete and stuff like that in there, and hopefully we'll continue improving that over time. And the bad, we're still doing exec fork like Zen Manager does. So we write an XL config, read from a database, write the XL config, and then call exec fork to do a lot of the stuff that we're doing. And that's mainly a function of the Go bindings that are available for libxl are deficient. So Nick's going to talk about that now.
Yeah, so there are some existing, there's an existing attempt at some bindings for Go in the Zen project repo and under the tools. And so when we were kind of going through our evaluation of Zen Manager and libvirt and other options for our tool stack, I did test those out a little bit. And they haven't gotten a lot of love over the last few years. It seems like it's been mostly abandoned. And I think in the current state they don't compile, but so that was why we decided to kind of take another stab at it. But Go lends itself well to this problem. Like most modern languages, Go has an interface to talk to existing C libraries, and the tool for this in Go is simply called cgo. As far as using it in your source, you simply import a pseudo package called C, and that allows you to see variables, types, and functions as if they belonged to that Go package. See some examples there. Is just size T, standard out. Oh, yeah, that's okay. Yeah, go up 2. We'll get there. That's okay. And another important piece is something called the preamble. And the preamble is just a block comment that you put in your Go source immediately before your import C statement, and it can contain any valid C code, as well as you can set kind of build flags, either like LD flags or C flags or anything else. You can do package config. And so this is where people will include the headers they want visible, do them in Go, and you could, if you wanted to, simply write C there and have it be visible to your Go function with some exceptions. So here's a very simple example of using cgo. You can see in the preamble, I just have the include for libxl headers, and so that allows my Go program to then see the libxl version constant. Go next one. For a few more details, some things just can't be expressed in Go because it just doesn't quite make sense. For example, C's union type is not supported in Go in the general case, so it might just be represented by a byte array of the same size. And if a struct field in C cannot be represented in Go, cgo will just pad that struct to reach the next field in the struct or to reach the end of the struct. And if you want to do things like work with an arbitrary pointer type, you need to tell the Go compiler using an unsafe dot pointer that you are acknowledging you want to break the Go type system and do that anyways. You can't call C function pointers from Go, but you can store them in a Go struct. They can be shared between the two languages. They just can't be called. And then there are other specific restrictions on passing pointers between C and Go, which is largely due to the fact that Go is a garbage collected language, and so the garbage collector needs to keep track of all of Go's pointers. Good, yeah. And so because the cgo is pretty straightforward, although very tedious to write, because you usually end up kind of literally translating from C code into just using the C dot statement. But because it's so straightforward, it does lend itself well to code generation. And so we're even using a tool called the C for Go, which is developed by XLab on GitHub. This has been used to generate Go bindings for things like the Vulkan API, Android API, and many more with some great success. It's very easy to use. You can pretty much specify your source headers and then apply translation and generation rules to those. So you can accept or ignore symbols. You can perform transforms on names if you want to drop the libxl prefix, or if you want to change from snake case to camel case, or any of those types of things. And so it's really flexible in that way, and kind of lets you pick the pieces that you need and exclude the ones you don't. So here's a couple of examples of what C for Go will generate. So here's just, we have the libxl, context, alloc, and free functions. And although they would be very straightforward to write, they would be very tedious. And so it's just kind of expresses the how nice the code generation is. However, those are not very nice to use from Go, and we want to have a more refined and familiar and idiomatic Go API, so I want to generate some wrappers. So this is a domain info function, almost literally translated from the existing C function in the libxl library, but it's very C-like still in the sense that it's returning an integer that will be set for an error code, and you still have to pass a context pointer and a domain info pointer in. And so we want to simplify this for using Go by only needing to specify a DOM ID to the original function. So you go next one. So end up with wrappers that look more like this. If you're not familiar with Go, the C star context here, that's just saying that this function is operating on that struct, but it's really just a syntactic sugar. This is equivalent to just passing the context pointer as the first argument to this function. And instead of passing the domain info struct, we leverage Go's multiple return value ability, so that we're going to return a domain info struct and an error. And so rather than checking an integer for an error code, we're going to just use the built-in error type and domain info, which is more familiar to Go developers. And finally, for some future work on the Go package, I want to continue writing wrappers to cover what we have generated so far. And we want to trim the size of the package because some of the APIs in the C code just do not necessarily make sense for Go. For example, the alloc and free functions for the context shouldn't be exposed to the Go API. That should all be hidden. And it is far easier to add an API as we see we need it than it is to kind of try to translate the entire package and have APIs that we either never get used or that we don't fully understand because it wasn't a deliberate decision. And so another goal is to then integrate this into redctl, because this will not only allow us to phase out our existing shell code where we're just calling exec and fork, but it also allows us to exercise this package and make sure that we have the APIs that are necessary and make it well refined. And then finally, we want to upstream it, because this is, as far as we understand it, there is still some interest for Go bindings in the Zen community, and so we're hoping to see this as a revival of the initial effort. So we'd like to push this through to the finish. And the current fork is that link right there, if anybody is interested in taking a look. So,
that's it. So if anybody has any questions or feel free to bring them up.
How is the safety check as far as Go is concerned with CGO? Is Go still as rigorous and
Yeah. When Go can, it'll still apply its same type system, so it'll do its normal safety. But if you remember on the one slide, there's a small package in Go called unsafe. So you can use an unsafe.pointer, which is you telling the compiler that you understand that that's breaking the type system. So if you need that flexibility to execute your C code, you have that option. But unless you're using that specifically, the Go code is still going to have its same type checking. Yes.
So I have a question. Have you found, I mean, obviously doing this kind of thing is always going to be a bit tiresome, but how have you found libxl for trying to wrap up like this? And are there things that, we could do better?
Do you have it?
I mean, the one thing that I've seen as far as libxl goes that would be nice is to even add to the command line piece support to dump the JSON in. So if you have a domain configuration as JSON that say you dump out normally from parsing an XL config, having an XL create like -J or something that you could throw that in there. And I think that would open up the flexibility to do, if there's like a single function call to go do that, because it seems like there's a lot of intermediary steps you need to do in libxl before you can take whatever the conversion of an XL config is to whatever its JSON piece is, and then taking that JSON piece and actually creating a domain. So I think if that point were more well-defined, I guess, I think that would be useful.
Right. Maybe we should talk about that offline. I don't think that's too far away.
Okay.
From I mean, not that anybody's working on it, but it doesn't seem like it would be really that hard.
Yeah, I agree. I mean, looking at it, there's not a whole lot of setup. It's just kind of strange that I feel like it's smack dab in the middle of a function. So.
Yeah, so I wrote the initial Golang bindings, yeah, I mean, I would have loved to, so I'm really glad that you guys have been able to pick it up, and I hope that someone would sort of do that. So whenever you're ready to push it upstream, I'm looking forward to it.
Is there anything that in your exploration of it that you saw that kind of hazards to avoid?
So what you saw in Tree was as far as I was using. So I had a Go program that I was using, and as you say, I was just execing XL, except that there were certain kinds of information that I couldn't get out of. I wanted to do XL DOM info basically, but that I didn't want to have to parse the text output. But and you can tell it, give me JSON, but but not all the information that I wanted was included in the JSON output of the thing, and that's essentially why I wrote the bindings in the first place, and that's why info works, and a bunch of the other random. So basically, the stuff that I was using works, but essentially the program that I was writing for, I had to abandon it, and I haven't been able to go back to that. So that's why it's sort of stalled.
Gotcha.
And yeah, but no, I mean I was pleasantly. So I was hoping to have some kind of automated thing. I mean so that it would sort of do something reasonable with the bindings and make it a much sort of automatic. So I'm glad that you've taught some automatic stuff.
Yeah, I think that's continuing to mature out there, the tool set around that.
Yeah. And obviously also to convert it to be so that the interface that you get as a consumer is, idiomatic Go rather than C-like.
Alrighty, thanks everybody.